Day 224 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem. This time we're at day 224, still going strong. And today we have question number 86, partition list. The difficulty level is medium, but don't worry, we're going to keep the solution as simple and easy to understand. So let's get into it. The question says, given the head of a linked list and a value x, partition it such that all nodes less than x come before the nodes greater than or equal to x. You should preserve the original relative order of the nodes in each of the two partitions. So let's look at the example so we can break that down. In example 1, we have the input head equals a list nodes or a list of nodes 1, 4, 3, 2, 5, 2. X equals 3, the output is 1, 2, 2, 4, 3, 5. So what they did, right? So since X equals 3, we took all of the nodes that are greater than or equal to 3. It says greater than or equal to X. In this example, X equals 3. So all of the nodes that are greater than or equal to 3, and we move them to the end of the node of the list node, right? So, and we move the ones that are less than 3 to the beginning of the list node. So that's why we take this 4 and we move the 4 right here, we move the 3 right here, and we keep the 5 over here because it says we should preserve the original relative order of the nodes in each of the two partitions. So in the input, right, 4 comes before 3, and 3 comes before 5. So that's why in the output, 4 comes before 3, and 3 comes before 5 because we're preserving the original relative order. And it goes the same with 1, 2, and 2. That's the original order. And the input, it goes 1, then it goes 2, then it goes 2. Those are all of the numbers that are less than 3. So we're going to keep that same order, and the output is going to go 1, 2, 2. And once again, same thing. In the input, it goes 4, then it goes 3, then it goes 5. Those are all of the numbers that are greater than 3. So we're going to preserve that original order as well. So that's why it goes 4, 3, and 5. So what we're doing, we're just grouping the numbers before that's less than X, and we're putting those first. And then we're taking the numbers that's greater than X and we're putting those next, right? After those last. So let's look at example 2 where it might get a little tricky, right? So in this case, the example 2, the input head equals a list node 2 and 1. This time X equals 2. The output is 1 and 2. And you might wonder, well, that's not the original order, but you have to remember with the numbers that are, or the node values that are greater than or equal to 2 have to come last anyway. And since there's only one number greater, there's only two numbers that we're working with, and the one number that's greater than or equal to, the number that's equal to 2, that's going to come second. So that's why it comes here. And the number that's less than 2 is going to come first. That's why it comes here. So that's what they want us to do. I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual code. But before we get into the code, y'all, if you need any new Apple AirPods, go ahead and check that link out in the description. Then after you do that, go ahead and like, comment, and subscribe. Now, let's get into the fun part, the actual code, y'all. So let's get into it. First thing we need to do is we need to initialize the current node pointer that's we're going to use to traverse the list. And in order to do that, we're just going to declare a variable called current, and we're going to set that equal to head, and that's going to start at the beginning of the list. Then we're going to increment it as we go on so that we'll be able to traverse through the list. Then we're going to come down here. We're going to declare another variable called left nodes, right? Left nodes, colon. Then we're going to say that's going to be a list node or an array of list nodes like this. Boom. Then put a question mark because they'll be optional. They might not be there. We'll initialize it with a blank array. Then we'll do the same thing for the right. So we're going to say declare another variable called right. We can call it right, that should be left nodes, right nodes, since it's an array. That's going to be a list of nodes as well. Let me see, list nodes, sorry y'all, question mark. Then we're going to say equals, that's blank array like so, right? And what these are going to do is these arrays are going to store the nodes that are less than x, and the nodes that are less than x we're going to put in left nodes, and the nodes that are greater than x we are going to put in right nodes, right? Because remember, we have to put the lesser of the nodes on the left side of the list and the greater of the nodes on the right side of the list. So these two variables are going to help us do that. Now we need to initialize the pointers for the new list head that we'll create that will point to the new list, right? And we need a previous that will track the last node of the new list. So in order to do that, we are just going to declare a variable called new head, right? Like so, and that's gonna be a list node. Boom. Then we're gonna do another variable called prev, and that's going to be a list node as well. Now that should be, let me see, that should be all of our variables. Let's get into the code. Now it's time we need to traverse the input list and categorize the nodes. So in order to do that, we are gonna say while current does not equal nil. So as long as there's a node where current is at, that's going to allow us to traverse the list. This while right here is going to help us traverse the list, and then I'm going to show you how we're going to categorize the nodes, right? So then we are going to say if current exclamation point dot val, just because it's an optional, dot val, we are going to say if that is less than x. What do y'all think we're going to do if it's less than x? You guessed it, we are going to append that to the left nodes array that we created up here. So we're just going to say, y'all, we're going to say left nodes, right, append, left nodes dot append, open up the parentheses, current. So if the current val is less than x, we're going to append that node to the left nodes array that we created up here, right? Boom. Now we have to do the same thing for the right nodes, right? If they're greater than x. So we're just going to say else. We're just going to say right nodes dot, it's going to be right, that should be nodes dot append current. So that's how we're going to categorize them if they're less than x or the greater than x. If they're less than x, we're going to append it to left nodes, so it'll be on the left side of the array. And if it's greater than x, we're going to append it to the right nodes, which will be the right side of the array. Boom. Then we just have to move the next node and the input, move to the next node in the input list, right? So keep moving on. So we're just, in order to do that, we're going to say current equals current question mark dot next. And now, so we're going to go through this whole while loop, and we're just going to keep moving through it. We're going to keep incrementing or moving down the current node until current equals nil, and then it's going to stop. Then now it's time, we need to combine the nodes from the left node and the right node to form the partition list, right? So right now there's still two separate arrays, and we still need to combine those arrays. So in order to do that, what we are going to do is we're going to come right here. We're going to say for node in left nodes plus right nodes, right? So we can combine them. What we are going to do is, first thing we need to do is we need to disconnect the node from any previously linked nodes to avoid a cycle, right? So in order to do that, we're just going to say node question mark dot next equals nil, just like that. Then we're going to come down here and we're going to say if new head equals nil, what we're going to do is we're going to say new head equals node, just like that. And what that is going to do is going to say if this is the first node, we're going to set it at the head of the list, right? So if we're at the first node, we're going to make sure that's the head of the list. Then we're going to say else, open up the question marks, and this otherwise we're going to link the previous node to the current node. And in order to do that, we're just going to say prev question mark dot next equals node. Boom. Then we're going to come down here and we need to update prev to the point to point. Then we need to update prev to point to the current node, right? And in order to do that, all we have to do is say, come right here and say prev equals node. Boom, just like that. And we're almost done. We're not done yet, because now all we have to do is say return. We have to return, excuse me, not the head, but the new head. Boom, just like that. So let's run it, y'all. See how it runs. Let's see. Ooh, okay, what's happening? What's going on? What does it say? It says, cannot find list nodes in scope. So what did I spell something wrong? Oh, this should be not list nodes. That should be list node. The variable is list nodes because it's multiple, but it's an array of list node that we get from right here. Sorry about that, y'all. So let's run it again. See what happens this time. Let's see. Okay, cannot find right nodes in scope. Where we at? Right nodes. Cannot find right node. Oh, sorry, y'all. This should have a T. Add the T if y'all didn't have the T for right nodes. It's these little pesky typos, y'all. You know, these compilers don't play about the typos. And it's accepted, y'all. So let's submit it. Make sure it stays accepted. Now let's see. Drum roll. And look at that, y'all. 0 milliseconds beats 100% of users with Swift. That's what I like to see. That's faster than a Bugatti riding past Andrew Tate and the rest of the brokies down the Autobahn, y'all. That's what I'm talking about. That's what I like to see. Now, before we go, y'all, get one more look at the code. Y'all, in case you need it. In case you didn't get it all the first time. Get one more look. Read it, learn it, love it. Boom. And I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.